Hello class, this is part 1 of the lesson on special segments in a circle. First, we're going to start with two chords, two segments that intersect in a circle. And when we have that happening, then we're going to say that the products of the measures of the segments of the chords are equal. What do we mean by that? So we have two chords over here, AD and CE. So we can break it up into two different chords. So the first one, AD, I can break it into AB and BD. So we're saying that if we multiply that, okay, so they're going to be multiplied, then that is going to be equal to the product of the segments of the other chord. So we have chord CE. I can break it up into CB and BE. So these two products should be equal to each other. So on the left side, we could say that that's the product coming from the two segments of chord AD. Similarly, on the right side of my equation, those two segments come from chord CE. So let's go ahead and take a look at applying this theorem to some examples. So for this first example, we're going to go ahead and find the value of x. So we have that this segment over here is x, this segment is 9, this little segment here is 3, and this other segment is 6. The theorem says that the products of the segments of the chords should be equal to each other. Okay, so I need to go ahead and multiply the two segments that belong to the same chord. So in this case, I need to multiply x and 9. So 9 times x. That will be equal to the product of the two segments of the other chord. So in this case, 3 and 6. I go ahead and solve this equation for x, and I need to go ahead and divide by 9. And I'll get that 3 times 6 is going to be 18, divided by 9 is going to be 2. So that means that the value of x is 2. So the second example says that we need to find the radius of the circle if the distance from the arc to the midpoint of the 6-inch segment is 1.5 inches. Okay, so since we're dealing with a midpoint of the 6-inch segment, then that means that these two pieces are going to be equal to each other, so that means that each one of them is going to be 3 inches. Now we're trying to figure out the radius, but before we get to that part, the only thing that we can figure out based on the theorem is that if we multiply this piece, the 1.5 inches, times the rest of that chord, let's just go ahead and assign the variable x to it because it is not known. So we're going to multiply those two pieces, so 1.5 times x. This is going to be equal to the product of the two segments of the other chord, so 3 times 3. So those are the two products that are supposed to be equal to each other. So solving for x, that means 3 times 3, that's going to be 9, and we have to divide that by 1.5. X is then going to be equal to 6. So from there, we first need to figure out what is the diameter so that we can go ahead and take half of that, and that will be our radius. So the diameter is going to be adding those two pieces together. So the 6 that we found plus the 1.5 given. So that means that we have 7.5 inches. In order to get the radius, we need to go ahead and take half of the diameter. So 7.5 divided by 2. And this is going to be 3.75 inches. So that would be my radius.